it? Streamy? Get the joke?
I get it.
Okay,
Yeah, I
okay,
know.
okay,
I was
okay.
okay.
Hello. I did spend some time adjusting my mic. I hope it's loud enough. Yes, I'm back. Like a bad penny. Before I begin, I just wanted to warn you that we are doing some testing and some other people are going to be talking about stuff around me. So anyway, in case you hear other people talking, it's a lot more important than the stuff that I'm going to be blabbing at you about anyways. Alrighty then. So, got a few people here watching. For those of you who don't know who I am, yes, I am Mike. Normally I do effects, but for the past couple months I've been learning how to do some things related to materials. And in the course of that I've been using Substance Designer from Algorithmic, which is a procedural material maker. And I talked about kind of the general theory about how it all works a little bit last week. I was a bit all over the place. I was kind of shotgunning, got a little distracted, wasn't quite as focused as I wanted, but anyway, what I said last week was that I would try to show you something a little more in depth, and I think that's what I will do. So, what I thought I could do is I would take one of our other materials, which is in Cube right now, which is not procedural yet, and at least begin to make a version of it, just so we can kind of go through the whole process. So I can show you kind of how it all begins, and my guess is we probably won't get too far in it because I'm going to try to explain a lot of things as I'm going, so it won't go terribly quickly, but at least you'll kind of understand how the software works, some of the theory behind how materials are made using procedural methods and so forth. So anyway, I will show you window. What I've got here is I'm just browsing through some of the thumbnails of our current cube materials, and these are the larger ones that we used to use. These are in the 2K format. What we do now is, since a cube material only spans 2 meters in either direction now, we're basically scaling things so that it will use about 1/4 of this current image, just so that the details within the image retain their current level of proper scale, but we're reducing the resolution of the images so that uses a lot less memory. And the cube materials that come out have to be 512 by 512 right now. For those of you worried about that, I would expect that sometime in the future we'll probably have the ability to let people scale those up on their computers locally if they have, better processing, a better video card, better capability. But for now, we're just trying to keep it low so that the memory doesn't blow out. Because there are quite a few cube materials. I believe there are something like 55 at the moment, and memory can expand quite a bit pretty quickly. The great thing about the procedural materials is that, of course, we can make the material and then it can be pretty much infinitely readjustable thereafter. So if, for instance, I make a tile or a brick or something like that, and I decide that maybe we want the bricks to repeat a little more, or we want the mortar to be a little bit bigger, it's hugely simpler to adjust those within a procedural material than it would be for me to take Photoshop files like some of these are and then try to hand adjust all those. Plus they can be totally randomizable in other ways, which is great. And as I mentioned last week, at some point we'll probably have games will be more likely to allow you to generate versions of it on your own computer and then have those tile more often or on larger spans on your own computer so that you don't see those problems. Anyway, so I went through some of the old materials and I was looking at them, just try to think of one that might work. It'd be a good example, wouldn't be too hard. And originally I thought maybe this one here, because it's somewhat simple. It's just a big beveled stone. But as all things are, this one is actually a little bit deceptive. It looks simple, but the devil's in the details. For instance, when you look at the stone here, you can see that there's lots of interesting chipping and extra texture going on, which makes this a little harder. So anyway, that was one option. There's this one. This one is also pretty interesting because it's got the varying stone sizes. It too also has some interesting texture detail here you can see on the surface of it, where some of the stones have different patterning on it. And that's really the key to making the procedural materials look much more realistic, is that individual stones are, quarried and cut, and they'll have slightly different characteristics. And you don't really tend to see one large pattern stretching across the whole thing, which is then kind of cut by the stone, either where the stones are individually cut, or the mortar, or the interstices here, like this. So the secret is to make it look like they're each individual stones and have their own qualities. So this one is an interesting one. And here's one which is more like a floor pattern. The problem with this one is that even though this is actually a photograph of a real stone floor, it itself kind of looks a little bit artificial just because it's so neat and tidy. I think the one that we want to do, though, is probably this one, because it's got some interesting stone shape going on in the individual cobbles here. Plus, it's also got some interesting stuff going on within the mortar. And now that I'm looking at it closely, I can even see that there is a slight seam here, which I should have fixed. But when we make it procedural, that will go away. So I'm going to kind of wing it here, going a little daring. I'm going to make this up as we go along, and I'm going to try to do one which looks sort of like this. Again, this one is the old double resolution one. So this one shows more detail and has more stones, because it used to span 4 meters, now we're only spanning 2 meters. So it would only go out this many bricks. What I can do is I can show you the newer version of the Photoshop file, which I already sized down. Which is that. So as you can see, same texture, just a quarter of it, and it's resized to be 512. This one's actually 1024. We do everything double resolution, the way it's going to come out in the cube in the end. So, where to begin? Let's see. One thing I want to make sure is that for some of these materials, I made substance versions which are not entirely procedural, but which make it much easier for us to export the files that are associated with them. So I didn't set them all up that way, but I did a bunch of them. So for instance, let me find an older one, hopefully that I've got working properly, like this one here. One of the nice things about Substance Designer is that materials do not need to be entirely procedural. They can take input from a variety of sources. So in this case, it references a Photoshop file, and what you can do is you load in a bitmap and you can link it, and by linking it, that allows any changes made to the Photoshop file to automatically update the substance. And in this case, all I did was I just took the base color part of the image here, and I did a little bit of processing in order to get the outputs we want. So for instance, I used one of the built-in nodes to calculate like a simplified version of the height. I used the normal map that I had already generated previously just directly. And I did some basic processing by removing the color from the image, and then just did a few little tweaks in order to generate a quick roughness value. So this is by no means really accurate, real world accurate. I just kind of fudged it, got it close enough to what it probably should be. But the advantage of this is that when we used to work directly only in Photoshop files, I would have to have Photoshop open, then I would have to export each of these layers into a document itself and then save that out as an individual TGA, which then our editor loads in and reassembles into a material. When it's a substance like this, after I've set it up, all I need to do is I just right-click it and I do export outputs as bitmaps. And then I can check off the channels that I want it to export, and it will automatically name them, put the correct postfix, which conforms to our naming standard on each of the ones, so the diffuse, normal, roughness, spec mask, etc. And then I just hit a button, save all, poof, it goes directly to where we save it on our server, and then I just use the editor to load it in and then assemble the material from there. So it saves me a lot of trouble. A little bit of setup at the beginning, but afterwards makes my life a lot easier. Coffee and textures in the morning. With that note, I think I'll have some coffee. Okay, so enough of this one. You can also, by the way, of course, make hybrid materials. I could use data or images that I've exported from, or that say John made in ZBrush. So he exported the height map he made in ZBrush. I could load that in as an image and then do procedural things on top of that, and then export it. Or I could make a totally procedural material like this. So again, let's just make sure I haven't already done a stub version of that one. that we were just looking at, which is Stone Cobble 004. And I've done a couple stone cobbles. This is the ridiculous one I did last week, and this is an older one. So anyway, I haven't done 004, so we will do that. I will make a new substance, and I have a template set up here for physically based CSC. That's our shader. And I have it begin at 2K by 2K just because I want to see all the details, just so that looks nice, and then I can scale it down afterwards. So we will do that, and as you can see, it will automatically generate all the maps for the outputs like this. And now we have a blank material. One thing I am going to add that I should probably add to my template is the height. And I can just quickly add that and then say its purpose is height. We're not actually going to use this exporting it, but as I explained last week, I'd like to see the height map or see the height data in the game or in the editor here, because it helps me visualize exactly whether the material itself is doing what we think it should be as far as its shape by looking at the photograph. So again, we're going to be referencing this and make something which looks kinda like this. We'll start out by making the height map, which is really the most important part. It's the thing you've kind of got to nail to generate, to really get across the feel that you want for the material in question. The color is done afterwards. At least that's the way I do it. For me, the color is harder, and that's probably good because then I won't look like too much of a fool while I flail around with that. But to be honest, we probably won't get terribly far anyway, even just doing the height map. So we'll see how it goes. But if I do any more of the streams, I'll probably just continue working on this material. Actually, this week what I was working on was wood grain, which is kind of tricky itself, and if I figure out anything which looks good for that, I'll get back to you on that. I might do something in the future on that. Okay, so what we've got, I'll put this back again for a moment, is obviously these stones like this, and fortunately for us, there are some options we have as the base generator. We have tile generator, and there's also a brick generator, and both of these will make the basic foundation of what we're looking for to describe these cobblestones. Now, each of them kind of has its own capabilities. My guess is that the brick generator is older because it doesn't seem to have quite as many options, and it's also a little bit limited in the way that it can pick sizes. And as you can see, we've got some interesting spacing and some size variance here, which we're going to need, which would be difficult to do with just the brick generator alone. So I'm going to go with the tile generator. This one. So as I mentioned last week, the way it works is that Substance Designer has things which generate data from nothing, like this, and it also has filters which take that data and manipulate. So what we can do to begin with is we will call this back and take a look at the image. So it looks like we've got about 1, 2, 3, 4, 6, about 6 stones across the top. Remember, this one wraps around. And maybe 5. Uh, so between 5 and 6, and the lengths vary on them. So that makes it interesting. We'll start with that. So I've got number X, number Y. By the look of it, about 8. In this case, exactly 8. So do that. Set this to number Y, 8. And next thing we want to do is we want to adjust how they're offset. So here, this control, the basic offset, is the global offset between bricks. So for instance, if we set it at 1 like this, they'd become tiles. But back like this, 0.5, it becomes straight running bond, where the middle of one brick is exactly bisected by the mortar of the brick below it, like this. Ours are a little more unusual than that, so what we can do is we can fiddle with this offset random value. We can make it totally crazy, like this. Ours are a little bit offset. We're also going to have to fiddle with the size, because the size in our original here varies quite a bit. So, and of course the great thing is that this stuff is changeable at any time, and so I can start working on it just to get some of the more interesting bits going, and then come back to the sizing and the offset, and it will still all work perfectly, more or less. So what we can do is, like here, we've got scale variation. And stones are pretty much the same size in our reference photo, so we don't have to make those too crazy. And also do other size things here, like this middle size. This is more for creating decorative patterning, where the size difference is still kind of regular. So you get, as you can see in this example, you get wide stone, thin stone, and it just alternates. What we may have to do to get the interesting sizing that we see here is a little bit fancier, and we're going to have to interleave some larger stones with smaller stones. And there's a way to do that. One possibility also is that there is an even fancier tile generator, which I have used a little bit, but it's got even more buttons and knobs, and I usually try to use the most simple generators I can, just to, so I don't get too confused. But there is one that's called Tile Sampler. As you can see, it's got a lot more inputs. Let me make sure that the inputs are visible. I will check display connector name, and what that does is that will show me a little pop-up over each of the inputs to remind me what it's actually for. Now this one is kind of nice because you can put in multiple shapes for the tiles. So for instance, like here, what I can do is I can create a shape, and I can have a disk, and I can make a different shape. And on this one, I could do, say, pyramid. Not sure why I would want to, but I can do this as input 1. And then somewhere down here, it's got a setting for how many inputs I want. I believe the big problem with some of these nodes is that the actual rollout, the control panel for them is so long and complicated, it's a little bit hard to find what you're looking for until you're really used to it. And I haven't used this node very often, so you'll have to listen to me stumble around. Here we go. So what I do is I set it to pattern input. It has some built-in things. This is true for the regular tile generator as well. And then input number. So I can set this to 2, and then now that adds another one. So now when I look at the tiles that it generates, I get a random mix between these two. And it supports up to 6, so you can go fairly nutty. This one, likewise, the tile generator, which I think I'm still going to use, can do the same thing, but, well, it does it in a different way. So I have two choices when I use a tile generator. I can use the default, which are built in under pattern type, like right here. And it's got a lot of the same shapes. We're getting to hear Andrew sing in the background on a recording when someone broke the build. So it can automatically just repeat lots of these built-in shapes as your brick or your basic tile. Or it can use an image input like the other one, where I can just use a shape which has all those shapes separately listed, and then input this image. So now it's on a square. I could even put it on a brick. And so forth. Now, the reason you might want to do this, where you input one brick and then have the tile generator repeat it for you, is if you want to do some other processing to the brick beforehand. You can get a similar result by using the built-in one, but then you would do processing on the entire image of tiles afterwards. So it's just kind of an order of operation thing. And in some cases you want to do this. In some cases you would just want to process the tiles after you've finished calculating them or processing them with the tile generator. So anyway, for now, what I'm going to do is I'm just going to use the built-in brick like this. going to use square. No, I lied. I'm going to use brick. And let's see if we can think of a clever way to get the sizing difference. So I will duplicate this. During some of my stream here, I may stop talking and just kind of fiddle with some stuff for a while, but that's okay. It's kind of just background amusement anyway. What I can do is I can turn on this random mask, which removes some of the bricks randomly. And then I can import this brick as the background into this. And so these fill up the holes here. And on these, I can fiddle with the size, like so. This isn't really what I want, but it's kind of interesting. And fiddle with the random mask. And I can fiddle with the blending mode here. Let's see what we can do. What I really want to do is I want to up the number of bricks and then just have them add into each other more to create the size variance. So making these materials is a lot of fiddling, problem solving, experimentation. It's kind of half the fun. This is still a little bit too crazy here. The size variance. What I'll do is I'll temporarily turn this off just so I can see these in isolation. This pattern specific setting here will soften the edges for me. Sometimes that works better than others. I'm also going to have to balance that out with how much mortar space I have right here. So you can see on some of these bricks the stones almost touch. Like here, but then we've got a wider gap here. And so I want the edges to be rounded, and I'm going to do some other processing to kind of get the unusual wavy edge on the bottom. And I just want to start out with something which is a decent profile. And again, making this up as I go along, so this is the first time I've tried to tackle this particular material. One thing we could possibly do is we could just go back to square like this, which might be the better choice, and then process the images afterwards to get the rounded edges. And I think that might be the wiser choice. Scale both of these down. Actually, one thing I think I'm going to do is I'm going to expose this scale. Like this. So that way, on this one, I can just use brick scale. And whenever I change one, it will automatically change the other. Yeah, not exactly what I want. Try something here to see if this works. As one possible way of softening up the edges a little bit. Bevel it in either of the two directions. I think what I really want is just filter on to blur it a bit. So use that. And the thing I'm going to do is I'm just going to leave this default value for now and then expose it later. It's a little bit of pain to adjust globally right now. Actually, what I'm going to do for the moment is I'm just going to process brick on its own. It's going a bit slower than I thought. I've forgotten about the variance in size on this. It's a little bit trickier to achieve. What we really need to do is do a little bit of a preview. Get an idea of what it's going to look like more in 3D. So this is not exactly what I want, but this is not basic gray color on here. But now we have a field of fuzzy lumps. Let me load up the cheat sheet document that I showed you last week just so we can get an idea of how this is all going to work as far as mixing it together. I'm guessing that an hour is probably normally not enough to really show you anything that's very interesting on this. But it is a bit of a slow process, especially when I'm kind of making it up as I go along. So, anyway, here's a bit of one I showed you last week, showing you the height map and showing you how you can kind of blend using different mathematical techniques to get the look you're after. And with the brick shapes like this, what we generally want is we want our cobbles, and then we want the mortar in between them to kind of be a fill level. So we'll generate a field of just mortar, which are all these little tiny stones and bits, and then kind of fill them around the bricks here to create the final look. In this case, one we normally do is, the one I normally do, is this. I use a max. So bricks here, which I'm not gonna fiddle with the size variance right now. I'm just gonna do some stuff to it, and then I'll worry about getting different size bricks later. Maybe I'll be able to show that to you next week if I do any more streaming. So we'll add a blend mode, like so. Then, for now, our mortar is going to be just, for the purposes of illustration, we'll just make it this silly yellow color, just so you can see it. I have to convert this to a color output so I can blend. It's going to cause me more trouble, so I'm going to keep it black and white. Much easier. But I'll make it this much lighter color here so you can see it. Alright. So now we've flattened out our little preview display here. And I will switch the blending mode to max. And what this does is it takes the greater value. So if the bricks themselves represent 0, which is the absolute minimum, up to white. So I'm using the full dynamic range to show the bricks, the height of the bricks. Again, I've got my scale here. At the moment, I'll just set it to 1. The size of this patch here is not terribly relevant. It can be whatever you want. It depends on the final pixel density of the output. But I'm just going to assume that this is, I'll say this is like a 4 meter by 4 meter patch. And later on I might zoom in on these bricks closer to simulate the 2 meter by 2 meter patch that I would see in Cube. So what happens here is, if blend the two, this top value represents the height of the mortar. So when I begin to put a texture on this, it will only appear in these areas. So for instance, I could do this. And add a little bit of noise. Just add black and white spots, which is a nice generic dirt looking thing. And in this case, use copy mode and this other one switch are basically a straight lerp between the two, so a linear interpolation. So I've got black and white spots, and then I've got my gray, and then I've got it set to do about a half and half mix. And the gray levels that come out of this are, depending on what I set the mix to be closer to this gray level here. So if I do this blend here and I make the opacity much lower, all the colors here in the end mix are going to be closer to this gray and thus closer to the overall mortar height. So when I do this, I can still make the mortar higher like this. My problem here is that I really need a little more contrast. I'm going to have a silly trick for that. Boost the intensity of a normal. Alright, there, good. Now you can really see it. This curvature filter is really used so you can isolate the cavities. It takes a normal map as an input and then it will filter it so that you can use the normal map and process the result to figure out where the cavities are and then do other interesting things. But it also turns out that it kind of makes this cool shading effect. And so what I have been doing lately is I just take this image output and then I kind of mix it in with something else to kind of provide a final interesting image on the finished texture itself, on the color part, just to kind of amp it up. Normally what you do is, again, I would use a blend like this. And, oops. Substance Designer has a distinction between pure gray data and color data. So whenever you switch from gray to a node which expects color input, you have to convert it. So in this case, I've got this set to color, which may be what I want. But what I will do is I will take this curvature output, which is pure gray, and then if I run it through this gradient map node like so, even though I'm not changing it, all I need to do is I switch it to color and it outputs color. And then I can blend it with this node. This is going to be unattractive, but it will show you what happens. So now I've got terracotta field of stuff. Anyway, but we don't want that quite so much. Just make it a little. Warm up the gray a little bit just so it's not totally cool gray. Anyway, so that kind of shows the basic premise of what we're going to be after in the end. I need to work on this height field again. Back, this is our original problem. So our spacing is still a little bit odd. What we can do is, let's see if we can scale these up a bit like this. One thing you have to do with bricks like this is that you have to play a lot with the scale, because as soon as you start adding the mortar or whatever it is in between the bricks and how that fills up between the spaces, sometimes it's a little bit hard to see when you're just looking at the grayscale map from above like this to try to judge what you're going to get in the end, because the height map data is fairly precise, and I can even switch to a 16-bit mode, which is even more precise, but that's not going to be necessary for this. Anyway, so there's a lot of fiddling with the scale and so forth, so that bricks get closer to where they should be in the end, but they don't touch. Alright, so I have a few minutes left here. Sorry, I've been a little bit slow trying to explain all this. But again, I'm kind of, well, I am totally winging this, so I should probably be more prepared. I don't really have a whole lot of time to do that lately. So what we can do with this to make it a little more interesting is we want to break up some of the edges. I got a few minutes left here. I'll try to squeeze some of this in. And a great trick you can use is slope blur grayscale, which is one of the favorite tricks of Substance Designer users. To break up the edges of anything to make it look much more natural. So in this case, what we'll do is we'll import the slope with the grayscale image here. And then what we have is this input for slope. And I will show you what happens. Let's start off with Perlin Noise Zoom. Alright, that's not so hot. But the secret is you set the number of samples up to a very high value, and then set the intensity down to a very low value. Now at the moment, what this is doing is it's just warping the edges. But as you get more detail on your noise, this Perlin noise is very smooth, and that's what causes the smooth warping. And to make it look a little more interesting, what we can do is we could say mix that in with this more grainy noise like so. This is not going to come out exactly the way I want, but it will illustrate my point. The blend node here, as you can tell, is probably the one you use the most, I would say. I think everyone would agree that you use a Substance Designer that has a lot of blend nodes. So what I will do is I will use max. In this case, we'll see what happens. And someone call that lunch. Anyway, so now that I've added some noise to this, you can see that it makes these edges more crackled. And by adjusting the opacity like so, reverse this, I can reduce the effect of it. Again, this is not really what I want, but it just illustrates the point. And by carefully layering this noise on the edge and then masking out the edges, I can get a very controlled, pretty realistic looking crackling. For instance, on my other test image here, I will show you. Gotta go here in a minute. But this graph here shows you the same thing that I was doing over there, but in a little more complicated way, where I'm layering up levels of Perlin noise on the same image. So I start off with this, and then I end up with this. And then you can see that it begins to act on the edges, like so. It's not exactly what I want, but hopefully I'll have a little more time. I'll have made some progress on this material by next week on the tile one, so we can see something that looks a little more impressive. Anyway, gotta go to lunch now. I will get something which looks a lot closer to this. Don't worry. It's a little bit difficult. I get a little bit self-conscious when I'm trying to explain things as I'm going, because normally I'm just working quietly away. Anyway, thanks for listening, and I will probably be back next week. We'll see.